glad to now kick off the 2 afternoon sessions, and I will not do that alone. But with me, we have Mania, Meibodi, and Bastian Vibranek. Mania Meibodi will be today our expert co-host, and Mania is currently an assistant professor of architecture and the director of digital architecture technologies at Taubman College of Architecture and Urban Planning at the University of Michigan. She studied architecture at the KTH in Stockholm, started a PhD in Luleå in the very north of Sweden, came back to Stockholm. This was the moment where we met and worked together at the KTH. She moved on to ETH Zurich, worked with Benjamin Dillenburger, and is now at Taubman College. Thank you very much for joining us today, Mania.
Well, thank you, Oliver. Thank you very much for the introduction, and I'm thrilled to join today. Let me start with slides. As you mentioned, just tell me if you see the slides right now.
Yes, looks
all right,
perfect.
Great. So as just mentioned, I'm going to say it one more time. I'm based at Taubman College of Architecture and Urban Planning at University of Michigan, where I chair the Digital Architecture Research and Technology Laboratory. So at DART, we are developing methods and technologies to disrupt construction, traditional construction, and rethink the way we design and build. We work at the intersection of computational design, hybrid robotic construction with additive manufacturing at its core, and material processes. We work a lot with additive manufacturing for concrete to explore the complex forms through algorithmic design and mathematical equation, but to primarily reduce concrete consumption and digitize the construction industry. Which also builds on my earlier work at ETH Zurich on Smarts Lab, where through 3D printing integration with computation, we achieve up to 65% material reduction. So many of our recent work has been on robotic 3D printing of polymer, looking at generating multi-layer and fully recyclable building envelope. The multi-layer will provide for integration of performances such as thermal control. We also look into how additive manufacturing fundamentally changes the way we design architecture. We can now introduce computational methods such as topology optimization, which results in complex forms to building, something we couldn't easily build years ago in large scale. We also consider the scale, production of large scale with no interruption. We develop fabrication technologies and careful resolution, complexity of branching, and explore these complexity in different ways. With this very last slide, I just want to highlight the challenges that we have with larger scale additive manufacturing, which is fast production, fast production and high precision as soon as you scale up, which we are looking into and developing methods for. I'll now move forward with my role today, which is moderating this session and introducing the speakers and their very nice work, which I had the pleasure to see. So let me stop the screen here.